right, guys, so we're done with algebra, and you guys have all taken geometry already, so we're gonna start getting introduced to statistics, so that next year when we're doing statistics, you kind of already know what we're doing and we can just have fun. We're gonna start with chapter 13, section 1, and this is your homework. So, problems 1 through 12, you're gonna do all of them. From problems 13 to 19, you pick the 3 that you like the best. It's all the same type of problem, same concepts, so you just pick the ones that you like better. Do 3 of those, and that's all your homework. This is a 2-day section, which means you're gonna have Tuesday and Wednesday, so really it doesn't need to be done till Wednesday evening. But of course, you're not turning anything to me until Monday, so it doesn't really matter. But just plan on spending half of your week on this, half of your week on the next section that we're gonna do, okay? So this section is called counting problems. And before we can really start doing any real probability, we have to learn how to do counting problems, which is the most basic type of statistics. So the problem that they go over in the book is John has 2 pairs of shoes, one black and one brown, and then 3 different color socks. Basically, they want to know how many different combinations could he have, right? Super basic problem, and you could just do it by saying, I can wear my black socks with my black shoes. I can wear my black shoes with my brown socks. But you can also just do it with math, and you don't, with 2 and 3 it's kind of easy, but what if you had 5 pairs of shoes and 7 pairs of socks? Would you really want to go in there and count each shoe with each sock? Not when you can do statistics. So there's a couple of ways of doing it. The first one you can do, which works fine because this is a small problem, is you have shoes here and you have socks here. Now shoes can be black or brown. Well, we're going to call brown R because they both start with B. And what are the 3 sock colors? He has black socks, so he can wear his black socks with his black shoes or with his brown shoes. Then he has brown socks. He can wear his brown socks with his black shoes or with his brown shoes. And he can wear navy socks with his brown shoes, black shoes or brown shoes. How many combinations is that? 6. That wasn't too hard, right? Because you only have 3 and 2, so it didn't take that long to make the table. You can also do a little tree. You have this guy, John, and the first thing they tell you is he has 2 choices for shoes. He has black and he has brown. And then they tell you he has 3 choices for socks. Black, brown, navy. So what does that mean? Here you have black, brown, navy. Okay? Oops. So you have 2 different ways you can illustrate that. This one is called a tree diagram, and that one is just a table. And again, that's fine because this is a problem that has really small numbers. But when you get into bigger numbers, or what if I said he also has 3 different belts, or 2 different pairs of pants, or all these ties, how many different combinations are there? This starts getting a little bit more tedious, right? So that's when you want to use your statistics. You want to use math. And what you do is you use something called the fundamental principle of counting. And it's in your book on page 523. What it says is that if a particular process can be done in 2 steps, where there are m different ways to do the first step and n ways to do the second step, then the 2-step process can be done n times n. So what does that mean? If you have 2 options for one thing and 3 options for the other thing, you just multiply it out and you get 6. So, like I was saying before, say he has 5 pairs of shoes, 7 pairs of socks. He has 35 different options. So this table and this tree would have gotten a little bit complicated there, right? So that's why you use what's called the fundamental principle of counting. Right, so in this case, m was 2 and n was 3. Multiply them together, we got 6. Super easy. Now, in the example that you have in the book here, it says how many different 4-letter patterns can be formed from the letters A, B, C, and D if no letter is used more than once. Okay, so they want you to draw out a tree, which I am not going to do, but if you look on page 524, you'll see all the possibilities. Now, they say to list all 24 of them, and then they show you the patterns that you can have in all of them. So those are all different ways to solve it. But could we use the fundamental principle of counting? Well, let's see if we get the same number they do. There are 4 different patterns that you can arrange. And how many different choices do you have? 4 different spots in the letters, right? So it would be 4 times, what's 4 times 3? 12 times 2 is 24. Is that the number they got? Yes. How did I come up with 4, 3, 2, and 1? That's what they have in the book, right? How do they come up with it? Well, what you're multiplying is how many choices do you have for the first letter? You have 4 choices, right? So that's your first one. How many choices do you have for the second letter? 4 choices. No, you don't. You used one of the letters already, which means there's only 3 left. So you have 3 choices. How many choices do you have for the third letter? Now you only have 2 because you already used 2 letters. And then you're down to just 1 letter. So that's how you end up with 24, right? Let's do it with an example that's a little bit simpler. And we're just going to make this up. We're going to go back to John. And he still has his 2 different pairs of shoes, right? And he has his 3 socks. But let's say he also has 7 ties. And now I say, okay, how many combinations are there? Well, we have 2 choices for the shoes. How many options for the second thing, which in this case is socks? 3. Because when you're using a shoe, that doesn't eliminate any of the socks. How many choices for your third thing, which is your ties? 7. So 2 times 3 is 6 times 7 is 42. That's how many possible combinations he has, okay? So in example 2, it was a little bit tricky, and they actually don't talk about this 4 times 3 times 2 times 1 until another section, but it's called factorial. I think I talked to you guys about it once in class, where basically like 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. So if I said I have 7 letters, how many ways can I arrange them? You'd know that it's 7 factorial. So 7 times 6 times 5 times 4 times 3 times 2 times 1. That only applies when you're using the same set of things for every position. When you have 3 different things, then you can do multiplying each number. However many choices you have for thing 1, for thing 2, and for thing 3. So it's a little bit complicated. You'll have to pay attention to the wording, and we're going to do so much statistics that you guys are going to get great at this, right? But fundamental principle of counting is you multiply the number of choices you have at each position or for each item, or how many choices for each group. It's however you want to word it, but you want to multiply however many choices you have for each thing. If you are using one pool and then you're going to take an item from that pool every time, you just have to remember to subtract that item from your choices. Okay? So we'll do more and you'll get practice on it. But in example 2, they show you all the different ways you can do it. You can do the tree. You can do all the different combinations and write them out, or it shows you how to do the factorial, which is what I showed you guys, okay? So look at that example and I will tell you guys what your homework is. So 1 through 12, those are all simple problems. They're for all of them. Process A and process B can be done the number of ways shown. So you have to give the number of ways that you can do process A and then process B. This is just the basic fundamental principle of counting. You're just going to multiply stuff out. Now, if you go to problems 5 through 12, they give you different instructions, okay? So for problems 5 through 10, it says if each process can be done in the given number of ways, find the total number of ways to do them all consecutively. Now here there's 1, 2, 3, sometimes 4, sometimes 5 processes. Same math, just a little more complicated because there's more steps. Now for 11 and 12, they want you to draw the tree diagram. They don't want you to use the shortcut with the math. You actually have to draw the tree diagram for both of these, okay? And for exercise 13 through 19, they're all problems. And so some of them are going to be straightforward like this. Some of them are going to be where you have to eliminate your choice because you already took it out basically. See which one you like better. It doesn't matter, but pick 3 out of all those problems and solve them, okay? And show me all your work. So that is section